we learned long division. We're still working on 2.3. So I'm going to give you one problem in 2 minutes for you to practice on it. I don't know why you need a calculator.
Simple stuff to make sure.
It'll take you longer to punch it in than it does just to think it out. Yeah.
That's a hard one. Are you making this up?
Yeah. I made it up. There's no telling. I don't know what the answer is. I'll give you all a minute, and then I'll start working on it. Don't wait on me, though, okay? Feel free to breeze right ahead.
Breeze. This is a breeze?
It is a breeze. You don't know how to do it?
I do, but...
Do it. Come on, Dallas. They'll be waiting on me. Waiting. You don't even have any words up there.
Yeah, I'm getting a BY on this one.
That's a BYE.
You almost have a point.
All right. Is this what y'all got? Anybody got a question? No? All right. You need to know how to divide using long division. Okay? You need to know how to do that. All right. So here's our plans. They keep changing because they're like changing all the tests and stuff. But anyway, sometime you're going to have a 50-point test. Okay? 50-point test. You cannot use a calculator. I'm going to give you a polynomial, and I'm going to ask you to list all these things. If you were in my PreAP Algebra 2 class, you took that same test. It'll be a different polynomial, but it's the same thing. Remember where y'all had to use Descartes' rule of signs and find all the roots, okay? So that's it. So that's kind of what we're getting into. All right, so did we talk any about synthetic division yesterday? No? Okay, so let's talk about synthetic division. Now, listen to me. Synthetic division can't always be used. This problem right here, you can't use synthetic division. All right? It has to be, first of all, you have to be dividing by a linear binomial. What does that mean? What does linear mean? Yeah, just an x. No x squares, no x cubes, just an x. What does a binomial mean? Two terms. Okay? So we're talking about you have to be dividing by an x plus 3, x minus 4, something like that. Okay? Then you can use synthetic division. Otherwise, you have to use long division. So, guys, the reason you have to learn it is because sometimes you're not dividing by a binomial. All right? So you have to know how to do long division. But if by chance you are dividing by a binomial, there is a much easier way, and it is called synthetic division. All right? Now, here are the things that you need in order to use synthetic division. First of all, what you're going to divide into has to be in standard form. What does that mean? No x's and y's, just x's. What does standard form mean? Means who's first? The highest exponent is first, and then they go down in order, okay? I mean, you could skip some if you needed to, but they have to go down. You can't write them all over the place. All right, the second thing is all powers must be represented. Okay? All powers must be represented. Now, remember yesterday when we did long division, and I said, you know, it's kind of good if you put those zeros in there, but if you don't, it just might scrunch your stuff up, and it might be inconvenient for you, but it'll be okay. Y'all listen to me. Synthetic division, if you don't represent all the powers with the zeros, it's wrong. It won't be okay. Okay? It'll make it wrong. The third thing is you are going to use the roots and not the factors. Okay? Now, let's just take a second and make sure that you understand what I'm talking about with that. All right? So, first of all, let's just play a little game. Factors and roots. See if you know the relationship. All right? So, if I tell you that the factor is x plus 7, what's the root? Very good. What if I tell you if the root is 6? Very good. What if I tell you the factor is 2x minus 3? Very good. 3 over 2. It's whatever you get when you set this factor equal to 0 and you solve for x, right? Set it equal to 0, solve for x. Here, you add 3 to both sides. That's where that 3 comes from. You divide by 2. That's where the 2. So the constant becomes the numerator and the coefficient becomes the denominator. All right, what about this? What if I tell you that negative 1/4 is the root? Do you know what the factor is? Very good. 4x plus 1. That's awesome. All right, so let's do a little synthetic division. This is example 4. Sorry, I don't know what happened to me. Example 4, it is, we are going to divide f of x equal to x to the 4th minus 10x squared minus 2x plus 4, by x plus 3. Okay? All right. So what's the first thing you need to check?
Make sure that all the exponents.
Make sure all the exponents, it's in standard form and they're all represented. So it starts and goes down, so I'm good there. 4, what? There is no 3. So we're going to need to put a 0 in his place. 4, 3, 2, 1, 0. Now, if you were in PreAP Algebra 2, do y'all remember that problem that I got y'all with on the worksheet? Because it didn't have a constant right there, and you didn't put a 0 in its place? Y'all listen to me. When I say you start here and you go all the way down, everybody has to be there. 4, 3, 2, 1, 0. If this doesn't have a constant, you'd have to put a 0 in its place. Okay? All right. So, synthetic division is kind of like fake division, right? So instead of being a house, we're going to be on the porch. All right? On the porch. My favorite place to be. No, on the porch. All I need is some little grandbabies to rock on the porch. One day, please, Lord, one day. All right. So, no, not now. Don't want them now.
Keep
No.
saying that, it's going to come.
No. Don't want them now.
I have grandchildren.
But no, knock on some wood. Not now. All right. So here we go. Now, look, synthetic division just takes out the fluff. You don't need that, the x's and all that kind of stuff. We just deal with the numbers, okay?
Yeah.
So, you're going to write the coefficients down in order. So, 1, what's next? 0, what's next? And then, perfect, and right. And then, look at that. Remember that number 3 right there? What goes out here? Negative 3. Okay, so let's see who remembers this synthetic division stuff. Remember this first guy right here? He gives you your starting place. So you just bring him down. And then you multiply. What's 1 times negative 3? And you write it down right here, and then you add. What's 0 and negative 3? And then you multiply. What's negative 3 times negative 3? And then you add. Negative 10 and 9? And then guess what you do? You multiply. What's negative 1 times negative 3? Positive 3. And then we add. Negative 2 and 3 make. And then you multiply. Negative 3. And then you add 1. Okay? Now, why do we do all that mess? That seems crazy, doesn't it? This last number right here will always be my remainder. And these numbers represent the coefficient of the quotient. That's the answer, people. Okay?
It would be 1 over negative 3 or 1 over
X plus 3. All right. So, and it always starts 1 degree less than this, right? Anybody know why? Why is it always 1 degree less? That's right. You just divide it by an x to the first. People, if you take an x to the fourth and you divide it by an x to the first, guess what you always get? 1 degree less.
So if you
An
divide
x
it
to
by
the
x,
third.
it's squared.
You can't. Not on synthetic division. Remember what the rule says. Okay, so that's why you can always say it's always 1 degree less. Okay, so what is my quotient? What is my answer? It is 1 what? X cubed.
Plus 1 over x plus 1 over.
Very good. Okay, so everybody got it? Y'all remember that? Going to bring you back some memories there? All right. So, let's see what else we got. What if I asked you to find, if this is f of x, okay, what if I asked you to find f of negative 3? What am I wanting you to do? Yeah, plug negative 3 in for x here. So don't get your calculators out, people. I think we can handle this. All right? So negative 3 to the fourth minus 10 times negative 3 to the second minus 2 times negative 3 plus 4. All right, what's the fastest, easiest way to raise something to the fourth power? Yeah, square it and then square it. Square 3 and what do you get? Square 9 and what do you get? 81. When you raise a negative number to an even power, it will always be positive. Okay, so that's 81. All right, what's negative 3 squared? What's 9 times negative 10? Negative 90. What's negative 2 times negative 3? Positive 6. And then plus 4. Okay, so let's see, what's 6 and 4? What's 10 and 81? What's 91 minus 90? 1. Hey, that's kind of weird, isn't it? Look at there. Those two numbers are the same. And it's not accidental. Okay? It's not by chance. They will always be the same. Okay? So look at what we did. Look at what that is. Yep. Well, it's not really a root. Okay? It's not really a root. But we're kind of calling it that right now because we don't really know that much about roots. But we're going to. Okay? But yes. So let's see if we can put that into words, because that is what they call the remainder theorem. All right? So let's talk about the remainder theorem. Okay? The remainder theorem. The remainder theorem states that if polynomial f of x is divided by x minus k, the remainder will be, oh, there he is. Yeah, f of k. Okay? Now look, I'm just, you really, somewhere back there in the deep recesses of your mind, you have this knowledge somewhere. Okay? So, I'm kind of just telling you some things, and then in the latter part of this week, we only have 2 more days. Oh, aren't y'all sad? Then, do what?
It's my last day this week, so.
Oh my gosh. Okay. Well, I got 2 more, so
Next week
be
is really
quiet.
screwed up too. Because our testing's on Tuesday and Thursday, and we're on Monday and Wednesday. No, we'll be in this class on Tuesday and Wednesday.
Oh yeah, y'all be in here, so we'll be okay. All right. Now.
Let's see, Spanish, English, law.
Now what about this? This is, listen, listen. What if, alright, Cain called this negative 3 a root, okay? What's another word for a root? A solution, a 0, a root, solution, 0, x-intercept, answer. All those things mean the same thing, okay? Now, why do they call them zeros?
Because where the intercept x-axis.
If you plug it in, what do you get? What does that mean your remainder should be? 0. So, he's really a factor. Okay? Now let's think about that for a second. No, I said he wasn't because his remainder's not what? 0. Alright? I said he's not because his remainder's not 0. But I haven't told you that, so we just called it that. Alright, so is 2 a factor of 6? Because when you divide by 2, what do you get for your remainder? 0. Okay, that's what tells us. Is 4 a factor of 9? No. Why?
You get a remainder of 1.
You get a remainder of 1. It doesn't go in there, what do y'all say? Evenly. Okay? So this is called the factor theorem.
I don't like theorems.
Okay? The factor theorem. Now, in order for something to be a factor, what does its remainder have to be? 0. Okay, so here's what the factor theorem says. It says x minus k is a factor of f of x. X minus k is a factor of f of x. I wouldn't say it there, but we're recording, so I need to be back there by the mic.
If the remainder is dividing,
What am I saying? X minus k is a factor of f of x.
I have 2 F's.
What is it? I'm going to ask what it says.
It says if, but it means something else. Okay? Now, first of all, I'm just going to tell you really quickly. I'm going to tell you why I do this to y'all, because I know sometimes y'all think, my gosh, why does she do that? All right? It's because even this year, I know that you're going to run into some things in college, and you're going to be like, what? We didn't learn that. I know you're going to. Okay? But I hope yours won't be as profound as some people's will be. Okay? Because you've worked really hard, all right, the last 2 years, and you've learned a lot of stuff, and you've been introduced to a lot of stuff, and you've been shown a lot of stuff. Some of it will stick, some of it kind of rolls off you like water off a duck's back, but hopefully if it comes back up again. So I had a kid, Gabby, y'all know Gabby, she's going to A&M, she's in a math class, so she texts me her homework and says, Miss Davis, would you look over my homework? I said, sure. So I start looking over her homework. I'm like, text her back, and I go, what class are you in? And she said, it's just an introductory math class for a business major. I'm like, what in the world? Y'all, huh? No. I'm like, y'all, it has all kinds of set stuff in it. It has intersections, unions, it has stuff in it that I didn't even know what it was. I had to go ask Mr. Ryan. I'm like, I've never seen this before. I don't know what this is. And he goes, oh, that's everything except what's in that set. And I'm like, oh, okay. Okay, so anyway, I worked on it and everything. And Venn diagrams and all that kind of stuff. So I wanna make sure that you're exposed to as much of that stuff as you can find. Okay? Yeah. And so this is a little piece of set notation. Now, we use set notation a lot, don't we? Okay, so how come I'm the only person that can do it? Oh, there it is, twice. Perfect, thank you. All right, so I want to make sure that you understand some set notation. We do element of, and we do the real numbers. We've done the integers, we've done the braces, and all that kind of stuff. So IFF means if and only if. Now, when someone tells me that, I go, oh, of course it's IFF. It's if and only if. All right? And here's what it says. X minus k is a factor of f of x if and only if f of k is equal to what? 0. Because that's your remainder. Okay? Only if f of k is equal to 0. All right. So let's do this. This is example 5. We are going to take 3x to the third plus 8x squared plus 5x minus 7. And we're going to use synthetic division to evaluate when x is equal to -2. Okay, now what could I do? Yeah, you could just plug it in, but that's not the way they asked me to do it, is it? Okay? They asked me to use synthetic division, so that's what we're going to do, because they want us to practice at it. Guys, that little 50-point test, if you don't know how to do synthetic division, you're not going to pass it. Okay? So, start at your highest exponent. Make sure everybody's represented. 3, 2, 1, 0. I write my coefficients down. 3, 8, 5, and negative 7. Okay, what are we dividing by? I don't know what's wrong with this thing. It drives me crazy. Thank you. Yeah. Negative 7. All right, so we're going to put a negative 2 out here. We're going to bring down our 3, multiply, and add. Multiply, and add. Multiply, and add. Now, is x plus 2 a factor? Why? Its remainder's not 0. Guys, it went in there, it has a remainder at negative 9. Now, what does that mean? What is negative 2 and negative 9? What do they represent? What? What does it mean? It's a point. A point. What's the point?
I don't know. That point where x is negative 2.
That point is negative 2, negative 9. That's true. That is a point. But what about that point? What does it tell me about the point? What? It's just a point out there?
The point in the,
On the what?
on the function.
On the curve. On the curve. Not a line, right? Because I got an X in the third. So it is. It's just a point on the curve. I mean, I could plug that into y equals, go to my t-chart, see where x is negative 2, and it should be y is negative 9. Okay? That's all it is. It's not a factor because I didn't get 0. All right? Let's try another problem. This one's a little bit different. This one says, this one's example 6. It says, show that x minus 2 and x plus 3 are factors of f of x equal to, you ready? 2x to the 4th plus 7x to the 3rd minus 4x squared minus 27x minus 18. Then find the remaining factors. Oh, then, sorry. Find the remaining factors. Okay, so let's just, I mean, you know, y'all listen, when you got a big problem like this, you just do it a little piece at a time. Like eating an elephant, right? A little bit at a time. So, first thing, let's see if we can show that x minus 2 is a factor. How are we going to do that? I'm going to use synthetic division because look at these numbers, people. You got some big numbers. They're going to be a lot easier like this. Now, what am I going to divide by? 2. 4, 3, 2, 1, 0. So I write down my coefficient. Now, what am I looking for? I want to get a 0, people. If it's a factor, then my remainder has to be 0. So I'm going to bring down my 2. And I'm going to multiply. And add. And multiply. And add. Oh, come on, you stupid pen. Trying so hard to be nice. Good night. We're going to have to get something. All right. And then multiply. And then add. And then multiply. And happily add. Hey. All right. So did I show that this was a factor? Yes, I did. I mean, physically, you can look there and say, hey, she divided. She got 0 as a remainder. It is a factor. Okay. Now, could I take this x plus 3, divide this same thing by negative 3, and show that I get 0 as a remainder? Okay. I could do that, but guys, listen to me. Yeah, that's what I'm going to do. Because this right here has taken this 4th degree down to a 3rd degree. Okay? Now, if you go back up there and you use those 4th degree numbers again, then you're just going to do what? Take it back down to a 3rd degree. Can you do anything with a 3rd degree? No, you can't do anything unless you can group factor it. If you can't, this one, it's not going to group factor for you. Okay? I was looking for a piece of chalk. Plus 18x plus 9. So what we're going to do is we're going to take that -3 and we're going to take this cubic down to a quadratic, and then I'll factor it and I'll have all the rest of it. Okay? Y'all remember this? This is what the 50-point test is going to be like. Okay? Except I'm not going to give you 2 of them. I'm not going to give you any of them. Okay?
How are we going to know what to use to divide by?
You're going to be guessing. We're going to use the you're going to be guessing, remember? But, now, am I going to come and teach you ways and say, hey guys, I guess from these numbers right here. Right? That's just a tool in your toolbox. Makes it nicer.
Wait, what? You're not going to give me some of the
Okay. Then we're going to do Descartes' rule of signs, and it might help you even more. Okay? Alright, so let's take that -3, and this will be the last one we'll do. Okay? Alright, and then we're going to bring down the 2. Multiply. What should I get for my remainder? 0. Better get. They told me it was a factor. They just asked me to show it. Alright, so if this doesn't, oh, good. 2, multiply, add, multiply, add, multiply, and add. So that means this is 2x squared plus 5x plus 3. You know what he factors into? 2x plus 3 times x plus 1. Perfect. So now we found the remaining factors. We showed that those were factors, got it down to a quadratic, and found the remaining factors. Pretty cool, isn't it? All right, you can go. Have a good day.